All right, welcome back to the studio. Today we've got something a little bit special on the bench. I've been wanting to build a Nixie tube clock on the channel for a long time, and instead of me fumbling through it myself, I brought in someone who actually knows what he's doing. This is Brian. Now, Brian is my go-to expert when it comes to soldering and circuit assembly, and today he's going to walk us through this entire build step by step while sharing some of the techniques that he uses when working on circuit boards. So stay tuned. So today we're going to assemble the Nixie tube clock kit, and along the way Brian's going to explain what it does and share some tips that might help you get better results when you're soldering electronics. And for those of you watching who like this kind of behind the scenes build content, don't forget we have our studio access and after hours members who get extra content from the studio, including extended versions of projects exactly like this. All right, well, let's get started. Brian, you're on.
All right, so now what we're going to do is, before I get started, I just want to wipe these boards down. They got oils and the manufacturing process and stuff. I'm just going to use my isopropyl alcohol. 99% is the best. This is not, but we're just going to wipe these down, get all the residue off of them, clean them up. You don't want that dirt in your solder. So just take a couple seconds. We're going to do a final clean when everything's soldered in. So we're just basically just getting the residue off. I like these. These are just makeup applicators. They work really good. They don't leave a residue. They don't leave pieces of dust and stuff from them. So I really like these. So first thing we're going to start with is we're going to do the resistors. Now, when you're soldering a resistor, you want to make sure that's the right one. The bands of color will show you. These are 5-band resistors. So you can use the chart and you can go through each one and see what they are. You can use a voltmeter as well, or a multimeter of some sort to use it. But I went ahead and saved us some trouble, and I went ahead and just marked up which ones and left them in packaging. So that way it makes it easier for me. Just I can look down and just see what I'm hunting for. So let's start with the 10K. So I'll take this resistor out. Now, orientation on these, it really don't matter, because you can, anyway, most components that does, but resistors it don't matter which way you put them in. And I'll just put them in through the hose, pass them through.
It's probably worth mentioning on those resistors, those cheap Chinese resistors with the blue bands are really hard to read.
They're really hard to, the colors in the blue, that's just not a real good look for them with the colors. So now, you'll see people bend them all the way down. I don't believe you need to do that. To hold them in, I just put like a 30-degree bend on it, and that'll hold it down. It'll stay in place with that. That way I can make sure that's completely around. I don't want to put the lead off too far to one side. And then let's begin. Thank you, Chad. So now my soldering iron is hot. It's been tinned. Let it hit it with a little rosin. Put a little more. Let's do it one more time. Perfect.
Yeah, I could never get a joint that nice.
So now we're going to put, I'm just going to look at the board. It's got, this is really nice, because this are really good. It's a build kit. So a lot of these build kits, they'll have exactly what the ohm should be on the resistors. So it makes it really for a quick one. Now I'm going to just put them all in and then solder them all. Everybody asks me, Chad, you look a little shaky when you do that. And yes, I am a little shaky. But over the years, I taught myself how to just work through it. Just shake. Once that shake goes the right direction, go ahead and solder.
It's all about timing.
So I'm just following the board. That's didn't get that bend on it. Now, by no means this is a professional tutorial on how to solder or anything like that. Everybody does it their own ways, but this works for me.
So why is it you put the resistors in first versus something else?
Well, because they're very small components, and you know, I don't want to get into the build and then have to. If you notice, you'll see as I build why these would be the easiest. I did watch a video, and that's the way they did it. If you know, I just think it's a better way because they're the smaller ones, and you got components on top of components, and their heat don't bother the resistors as much as other components. So I just think it's the best way to start with them.
Start with the smaller components first?
You always start with the smallest components. And visualize when you're doing anything, a project like this, visualize the final, you know, the last few parts. Is that going to be in your way of what you're doing next? So I want to make sure I get the stuff that is small, tiny, closest to the board. If there's something real close, like if I got a resistor real close to a chip, I want to do the resistor first. If I got a capacitor close to a chip, I want to do the capacitor first. Just the way I've always done it. Now, what's nice about this kit, I'm sure he'll put a link up to the kit, but they give you extra, so you don't worry. You didn't leave anything out. They just give you some extra stuff. We get to some other components that I'm really glad they gave us some extra stuff. So now once I got all my resistors in, I like the placements. I'm going to start bending. It's always better to bend both leads because, you know, if not, you'll have one that's sticking out like this one wants to do. So now I flip it over. Now we're going to solder. Now, if you notice, I try to not really hit the board with my soldering iron. I'm taking it and I'm going down to it. Now it's going to happen, but I'm melting the solder, and the barrier, I'm trying to place a little barrier between when the solder gets hot, and then I want to touch the board and the leads with the hot solder, not with my iron, so to speak. You're going to hit it. I can hear, but you might even pick it up on the mic, the noise, but there's some places you just can't help it. Everything looks good. I don't see no cold solders, cold joints. I'll cut these leads off. Yeah, here's another thing too. If you look, now if you notice right there, I don't know if you could see this, but you'll see I can see space in between there, and so I can see space in between that one and that one. So what I'm gonna do is I'm gonna flip it back over, and that means I just didn't run enough solder down through the hole. I'm just running that down the hose a little bit. Now I'm going to flip it over. Now you can see how that's closed up now? I can't see through them holes. They're closed up. This one could use a little bit more. Now, to be honest with you, I intentionally did light solder on it just to show you what happens. Because that what happened is that'll create it's only soldered on the one side. It could possibly, by movement or something, it could break loose, and then you're going to have a problem. And sometimes them are hard to diagnose because it's working sometimes and sometimes it don't. Just depends on, you've had the plugs that you hold the plugs down, you have to hold it that way. That's where the resistors will be. So I just kind of do it like that. I'm sure somebody's going to flame me for saying that, but that's okay.
Everybody's got their own way of doing it.
So when I cut these, I don't want to cut them on the solder. I just want to cut right above the solder. And that's where these are perfect. And Chad will put a link to this. This come with a kit that had some of these on there. Because what these do, I could just basically put this down and it cuts just right before it. Basically, I'm setting it down onto the solder itself and then clipping it, and it just leaves the perfect length every time. And there you have it. There's the resistors in. So now we're going to move on. We're going to install a diode. So I'm going to kind of clean up a little bit. We'll check my iron. Because if you're going to, anytime you're soldering, especially with this type of station here, is you want to make sure that if I'm paused for any minute, you got to use the restroom, you want to pause, go ahead and flip this thing off. Because what happened, it's just hard on the tip. As you can see, just me sitting just that few minutes cutting them off, you can see the tip. No big deal. Get it wet, wipe some of that off, run it through my temp cleaner, put a little rosin. I just kind of, after that, I kind of wipe it back off again. As you can see, it's cleaned it all back up. So I'm going to go ahead, before I talk about the diode, I'm going to shut this off. So here are diodes. Now, when you're looking at a diode, the stripe indicates the cathode. So the cathode is this side here. This matters in the direction it goes in. The one without the stripe is the anode. And here's what's really nice. If you notice on this board where the diode, where a lot of them, I don't see it on the diode, but where a lot of them go, it'll give you the stripe. But a lot of times you'll see a square pad. That's the cathode, and the anode's round pad, that's really nice. They do that. So it may be on the bottom. No, it's not. But a lot of times they'll put they'll give you the square or the circle. But I know it makes it pretty easy. As you can tell, let me get my pointer here. You see the gray stripe, and there's that part on the board is striped. So I'm going to verify 106 ER106.
And whenever I watch somebody else soldering, it always makes me realize the stuff that I'm missing from my solder setup. If people watched my Nixie 2 multimeter video where I had my soldering station and stuff out, that's about all I've got. I'm going to have to keep up with the Joneses here, I think, and get a nice big mat and all that stuff.
This mat, I've wanted one of these I have a smaller one, and I've wanted one of these for a while. And the bigger one, but I mean, there was $50, $60, $70, and I found this one on Amazon. I could say that, right, Chad?
Yeah, you can say that. Yeah, not sponsored.
Right. So for $20, and I just couldn't beat it. I said, well, I got to have that.
Yeah, and a lot of times with me, with soldering stuff and everything, my brain is stuck pre-Amazon where everything was ridiculously expensive, and that's really not the case anymore. People that want to get into soldering or building these kits, you can go on Amazon and pick up everything you need for way less than it used to be having to buy stuff from a local electronics shop or Radio Shack before they went out of business.
Yeah, and as you can see, I just made a crucial error. So put this in the record book. I did not turn my soldering on before I tried to solder. It's all right, though. With these stations, they heat up so fast. I remember when, as a kid, you would have to plug your soldering iron in and wait. And then when you got soldering, that created a little problem for me. This is good, though.
Well, yeah, we leave the mistakes in, and because this is real life.
So I'm just going to clean this board back up because I got a lot of rosin around the rosin's around it. So now it's not one to solder. This is not going to be a pretty solder joint, but we'll clean it up.
Well, this is real life and what happens. A lot of the videos.
I know, but it's not supposed to happen. But
well, a lot of the videos you see, people cut out the mistakes or the bad parts, and people don't know what to do when it happens. So if anything happens, we just leave it in. That's part of the thing on the channel. People get to see the mistakes, the failures, the successes. I just show it all because it's real people doing real things.
So much easier that one went in that didn't have that. I hit it with a cold soldering iron. I mean, it was probably about 400 degrees, but it ain't. It's enough to get the rosin going, but it ain't enough to melt the solder. That's Celsius, by the way. So now we got it. We tackled it. But as you can see, it looks a little sloppy, but it'll be all right. You just wouldn't want to do that on some of the other boards and stuff for sure. But we got the diode in. Thank you. as you can tell, I don't do videos. Chad just asked me to do this, and I was super excited about it. And I love shooting these leads off all over his.
That's what I've got the Roomba for.
Yeah. All right, so we got the resistor in, and I like to check my work constantly. You can see everything's parallel with the board, vertical. I'm kind of an OCD person about that stuff. So moving on. So now we're going to go with the optocouplers. Now, the optocouplers they're really neat. What they are is they transfer signals between circuits using light isolation. What it does is it puts a barrier between the two circuits. So it uses, in one of these, there's a little LED light that there's a signal that tells flip on. There's a pickup that sees that, and it's like a switch, so to speak. But there's a barrier. There's no, between one side of the circuit to the other, it's between the two.
So correct me if I'm wrong, you would use those in circuits like this where you have a low voltage side and a high voltage side.
Exactly.
And you don't want them to couple.
Exactly. You don't want, it gets that out of there. So if you look at these, you'll notice there's a dot. See the little dot right there? I don't know if you can see, it's kind of hard to see, but there's a dot right there. And you notice there's a dot on the board. Again, orientation's key when you do this kind of stuff. That's why I always, anytime I build something, I want to, surely you could just start putting them in as a video or the instructions tell you to, but I like to look and see what I'm putting in, what it does, why it does what it does, where it goes to.
Yeah, it's a good idea to dry fit your stuff first before you start slopping solder everywhere.
So that was pretty, now I'm going to put all 4 of them in here. And there's a little bit of a technique when you solder these, because these are very thermal. You cannot get these too hot, because if you look at it like this, this is a light bulb on an LED in a plastic case and on the other side. So if you get them too hot, that little bit of area there could collapse, or you could mess them up. All right, now I do my own little technique with this. There's 1, 2, 3, 4 here, and this is one, and so on and so forth. So what I'm going to do is I'm going to do a little pattern. So I'm only hitting at one, and then I'm going to move to the next, and then go back and forth. And what that does is that will keep the heat down on the component.
And that's true for like ICs and stuff too. You generally don't just hammer all of them down. I've seen a lot of people go one pin on one end and another pin on the other, and then work their way back and forth.
Absolutely. So I'm just going to repeat the pattern again, do the other side. To rosin core solder. And see, that's another thing too, is slow down, make sure you're cleaning. I notice I start soldering with a dirty tip, and you'll see it as you go. As you can see, I see the rosin coming out of the solder, and it'll start building up on the board, on your tip, and it'll just give you some dirty solders. So now let's move on to the MOSFET. Okay, this is the MOSFET, and it acts like a voltage controlled switch that allows the current to flow when the voltage is applied to the gate. So that's what this is. It's a MOSFET. You'll see a lot of these. If you take a car stereo amp or any amp, you'll see it. This is a very small one, but you'll see them a lot larger in things, but that's what this is. So I know it's going to go here, and I make sure I check the orientation of it. So now I'm going to put the MOSFET in. I'm going to bend it just to get the good 90. I don't want the metal part touching the board. In some cases you do, but in this case you don't. And if you see if there's a pad on the other side, it's probably all right. And because you see, you don't want that, see them holes right there? I do not want that touching that part. So I'm going to stand it up, probably put a little spacer in here. So now, as you can see, I started it. Now I can pull a spacer at, and you can see there's an ever so slightly little gap in between there. I want to be able to get to the holes right there if need be. And I'm not going to solder where I just orientate, because if I heat that back up, it's going to move that MOSFET. So I want to get a good strong solder on one of these other ones first. That looks pretty good. And sometimes I've learned this from experience too, is you're trying to get that perfect looking joint, and every time you touch it, it just gets worse. Well, your Roomba's, he's gonna love it. It's gonna love it tonight.
Yeah, I hear those things ping off the walls.
Now you see how that's up off the board, but it's laying pretty flat. I mean, it's not perfect parallel, but it really, I mean, it's down far enough. So now we're gonna move on to the Nixie chip, the driver chip, which is here. Now, you'll notice on this, there's a dot. See that little indentation? And there's a dot on the board. That gives you reference on how it goes in. So, see my dot, there's my dot, and the dot, where that cut out right there, let me show you a little better, right there. So that tells me the orientation to put it in. So find the dot on the board. Now take your time doing this, because these pins will, they're never perfect unless, wow, that one went right in. So this one must be the one that's going to be the difficult one. So I want to move them together. Now they came out. So I'm going to just kind of push this in, both of them in just a little bit. Still need a little bit more. And I'm going to push them in equally. I don't want to have where it's off one side or the other. So I think I got most of them in now. There's just one little guy here, and that's it. So I'm going to check before I press at all. Any pressure, I want to make sure. I'm going to turn it over. I'm going to look at them. Now I'm going to press them in, and you'll notice where the leads get a little bit wider. So I'm going to go all the way down to that. And what's funny, if I have put chips in before, and you're like, there's no way they can come out. There it's the end, because you had to push it in or whatnot. But then you flip it over and it just falls out. That's fun. So now I want to make sure I have a really clean tin soldering iron right now, because I don't want to spend a lot of time, a lot of heat on each one. Just want to make sure it's really clean and it's really tin. So my soldering tip, when I'm doing this, it should be shiny. You want it to be shiny the whole all the way through it. Check your temperature, make sure you're on the right temperature. I'm running about 750. So you just go to each one. And once you get a rhythm with this, it should go really fast. Okay, so you see, notice I bridged that a little bit. So what I'm going to do is, there's lots of ways to fix a little bridging. That's actually a really good thing that happened right there, and not on the Arduino board. But so I'm just gonna take my tip. I'm gonna just try. I resolved it, so it's done. I'm gonna move it over, move that solder over just a little bit. Move this solder over just a little bit more. Now you can see there's a gap. That's going to happen to you. Now these are not real close together. A lot of stuff I solder way closer than that, but that's a good it happened there because it's an easy fix. You can basically fix it with a soldering iron. There's other ways to fix it. You can use flux. You can use solder wick. Some cases, be careful. They make these little tools, these little scrapers. You can heat it, scrape, but just be careful because I don't like to scrape boards with traces all over them. This board's pretty cut and dry. It don't have a lot of tiny traces. So right there where I bridged it, I'm not real happy with that solder. That looks like it's something that become cold, and when you cold solder, won't stick. So there, as I made the ice cream tip, I named it that. I don't know. It might sound stupid, but I named it. So now I just put it back the way I like it. And there's some little, on this, there's just a little bit too long, so I'm just going to gently cut a few of these. Feed the Roomba. As you can see. Now, I'm trying to not cut the solder, but I'm going to get into it a little bit, a few of them. You don't really, it kind of, when you're cutting these off the board like this, it puts a little stress on the board. All right, so that's in. So we're going to move on. So the next thing we're going to put in is the variable resistor, which is this guy here. There's really no wrong way to put it. It's a 3-pin. As you notice, it's got a little place you could for a screwdriver. What this does is the resistor controls the brightness of the Nixie tubes, and make sure, don't adjust it. If you do not know what you're doing, I don't know what I'm doing with that. I would have to look it up and see because you don't want to overload. I don't know how crucial it would be, but I'm not going to take a chance. I'm just going to leave it. If there's something wrong, I'll go back and do some research and find out if there's a way to adjust. If I want it brighter, I won't mess with it right away. Now, heat ain't too bad with this one, but you notice it's in a plastic case. So I'm not gonna put a whole lot of heat to it. Kind of do the same thing I did with the optocouplers. Just kind of buzz it real quick. Done. Cut my leads off. I'm one that always like to look over my work when I'm done, make sure everything's square. All right, so we got the variable resistor in. Now let's do the capacitors. All right, so you'll notice they're marked. That gold stripe is telling me that's negative. That's positive on this side. And you notice that each one, let me show the solder cam. The leads are longer on this. And what that's telling you is the shorter lead is the negative, the longer lead is the positive. So this is one that you have to be careful on. You have to look at this board. So you'll notice on this board, I can assume it would look like that would be a negative up here. But excuse me, it is a negative. But this dash right here is what I'm referring to. So that's just telling you it's a 4.7 microfarads _ 350 volts. But you know, if you didn't know any better, you would think that might be a negative. So I'm going to match them up. 4.7, 400 volts. The other one is the 470 microfarads. Now, even though it says this is what they sent with the kit, so between the 50 volts, that's not no big deal at all. So the way I want these capacitors, they kind of stick up. So the way I want it, I kind of want it leaned over. So I'm going to go down, get a little reference bend going, and I want it just to lean over. Where you've seen them when they're in, you take apart electronic, it's kind of leaned over like that. So that's what I'm going to do. Now it's leaned over a little bit. So now when it's kind of, the back part's kind of pushing down on the board. So that way when I solder it in, after I solder it in, I can lift it and make it parallel with the board again. Okay, and I'll just lift it up just ever so slightly, and you can see it's not touching the board. And if it is, that's not a real big, it's insulated. This one, there's really no place to, I don't want to bend it over because, yeah, I can bend it a little bit. Take your time. Here's a good example too, so you know you have it right. So you see the board says ground and 5 volts. I'm going to go ahead and check. That's my negatives. So I could see that lead going over to that 5 volts, so I know I have it right. Capacitors are in, orientated the right way. So we're going to move on. Now this right here is the Arduino Nano. That is the control board. Basically, that is the brain of this whole clock. There's another component we'll get into. It's at the actual clock, but this is going to control the driver chip. It's going to control the clock. It's going to control the tubes, and that's what this does. It comes in this kit pre-programmed. Of course, I had to plug it in and pull that program off just to look at it. But it's already coded, so there's nothing you really have to do. But you're going to put it here, so we're going to use these header pins. So I want to use, we talked about this earlier, of what's the orientation we're going to put it in, because there's a short side and a long side of a header pin. So I think we both agreed that this would probably be the best way, is put the short ones in, so I wouldn't have to cut the bottoms. And I mean, you could shorten them up, but I just don't see the purpose in that. Just leave them alone. So now you'll notice that square. Do you see that square box right there? That's the USB plug. That's the programming port. So I'm going to put that in the right orientation. And the reason why I'm putting this together like this is because when I solder them header pins in, if you don't have them straight up plumb, is that you'll have to take it back off and resolder and get it straight. So now them pins are a little tall. But so now when I flip it over, I'm not worried about this board. All I'm trying to do is keep the pins straight up and down.
Oh, that's a good tip. I wouldn't have thought of that. I didn't end up with crooked pins.
Well, you'll end up like when I was putting that driver chip in, I was trying to mess with all the pins. Well, these pins, header pins, they're not as easy to bend as the others. And these kits like this, I mean, they make lots of kits for a lot of things. And what's nice is it sharpens up your soldering skills. So when you do a repair, if you have a repair and you got a tight spot and you got a little bit of skills, you've got a lot of practice on these little fun projects.
Yeah, when I got back into soldering 5 or 6 years ago, one of the first things I did was pick up a little $10 digital clock project on eBay and built that. It helped. It really does help to sharpen your skills. And if you screw it up, it's only a $10 project. So maybe start with one of those if you're not really skilled before you move up to something like this, because it's a little more expensive than those cheap ones.
As far as the skill set of soldering, this is pretty easy. But again, if you've never done it, or if you're, did it, soldered a wire back into on a board or something like that, it just takes time and practice. The right stuff too, that's big. The right type of solder, the right type of soldering iron. And I like the solder stations. I've used this regular hot iron, but they don't have temperature controls in them. So, if it's whatever the wattage is, it's just going to heat up, and just stay on. Where a station actually monitors the temperature. These stations actually monitor the temperature, and they'll turn on and off as needed.
Yeah, compared to the past, they're a lot less expensive too. The tips are cheap. You can get a replacement iron if you need it. That is one good thing to happen.
Now, I'll show you why I left this on. So now I can pop this off. My pins are straight up. Now watch how easy this is to go back on. Boom, back on.
Yeah, good tip.
So now I need to have a little bit more care, because now I'm around, this board is small. This is not, the Arduino board is a small board. So you can see it's got surface mount components on it. So I want to take extra time, extra careful, and when I move with this. Move with purpose so they don't.
Yeah, the last thing you want to do is float one of those surface mount components off of there.
Or cut a trace, or bridge something. And these pins are so much, the diameter is so much bigger than the leads on these other components. When they're hot, they are, you notice I had a little ball right there, so I just want to take my brush here, it's kind of hot, so then I'll take my tweezers, I want to get that off. Careful, and it's off. Because that's a hot piece of solder, and if it falls into this area right here, and just say I touch it with my solder in there, now I just bridge that chip. So get it out of the way, get it out of there. Now see, I'm right over them octocouplers, and this part of your soldering iron right there is really hot, so just got to spend extra time. So I'm just taking a little longer time right over the top of them. Okay, expect my work. I'm pretty happy with that. What do you think, Chad?
Looks good.
So, to cut these or not, I think I'm going to cut them. I've been kind of debating to cut them or not. Let's try to cut one, see how, they're going to be a little harder to cut than the other leads. You only want to cut these one at a time. They're just going to go down in the studio, Chad. I'm sorry.
That's all right. That's what the Roomba's for.
Yeah, in my basement, you don't walk barefooted. That's for sure. It's just to that height that I'd rather cut them than have them something, maybe press on one or something and then get them touching. Short something out. Well, it sounds like they're all going in the same place.
Mm-hmm.
So the next thing we're going to do is we're going to put this little bitty choke in. Now, you've all seen these in amps. It's that magnet that's got the copper wire. This is the tiniest little one I think I've ever seen. What the choke does, it's a small coil, and it's used to filter electric noise and stabilize the circuit. It has no polarity, and it can be installed in either direction. So I've already this kit came with two. You only need one, of course. But I went ahead and kind of put it in because I didn't know exactly how I wanted it to sit. I try to find the flushest way I can put it on the board and not touch anything and not touch the board. So I kind of come up with that. It's kind of ugly, but I was watching the videos and they turned them and they had them different ways, but I think I'm pretty happy with that. So I'm gonna go ahead and solder that in there just like that. You know, it's not an exact science of where the positioning. In the perfect world, yes, I'd want it to go. I would want to turn it and go 90, but I don't really have enough lead to do that. And you know, I don't want to fool with it. You know, it's a pre-made thing, and I don't want to mess with the leads and get it broke or something. So I'm going to leave it like that for now. If y'all have a better way, let me know. So I took a little pause here, so I want to make sure and that's another thing. So as I took a little break, and so I turned my soldering iron off, but I just want to make sure it's perfect. So now it's all nice and shiny again. And I just want to put a little dab, get that going, little water sponge, and then now I can solder again. Always make sure that tip, always check your tip, clean your tip. Okay, so now that's soldered on. So I just want to cut the leads off of it. We're good to go. Now, moving on to the clock. Now, before we get too much into that, now this is the clock. You can see it's got the little battery or whatnot in there. This is the actual clock. So this is what keeps the time. And the way you put this in, I think there's a better way, but I'm going to do it the way it was showed. Is I'm going to take this plastic piece off. It's just a header pin, female header pin. See, take that off, and you notice the little forks. So I don't need two of them. So what I'm going to do is carefully, very carefully, is I'm going to cut each one off, so it's just a single lead. Just take your time. Don't cut two off. Don't cut both of them off the same one.
So they basically just supplied an off-the-shelf clock component that you have to modify just a little bit. Another
thing important: if you cut the one on the right side, then you need to continue cutting the one on the right side all the way down. So I just kind of dawned on me. I'm going to take and I'm going to bend these out so I don't accidentally cut the wrong one. See, I just bent them out a little bit. So now I can take this side of my my cutters and just kind of slide it. See, now there's no way I can cut the other one. So now I can slide it. But before I do that, what I want to do is I want to protect this battery and this board. So we'll just take a little piece of tape. I'm just going to put it right down here. Theoretically, just slide right in. Because now you see that, as you can see, that battery's touching the board, but I got a piece of tape. I'm using masking. I would probably use electrical, or even if you had some thermal tape, which thermal tape, you could solder around it and protect circuits. When you're working with a lot of SMD stuff, surface mount stuff, that's a lifesaver to have, because especially hot air. This has got a hot air station. You could use that thermal tape to tape over the smaller surface mount capacitors and resistors and stuff, so you don't blow them off the board. So there's my clock. Now it's installed. So moving on, we're going to use the header pins. They sent, this is the header pins they sent. And there's a female and a male. So I'm going to put the female onto the board down. So I'm going to cut. So I got, what I do is I just kind of look, take my little scribe and mark these. Now the kit, I don't know if it looks like it has a lot of extra. These are, if you do projects a lot that has a lot of header pin, go on Amazon, get you some extra ones, because I got some extra, I have some extra ones here, but I want to show, if you do cut, sometimes you accidentally cut more than what you want. But the best way to do this, there's a little thing, I'll check it again, make sure my mark's right. I want to cut the closest one that I don't need, because then I can always cut off excess. I can't make it get any longer though. So I'm going to cut it. You notice that pin's right there. I'm going to cut it. That pin should fall out and you should have a perfect cut. Now that takes, to do that, that takes a little practice, because I've done it 100 times, hundreds of times, but I still every once in a while will cut one wrong. I may do it on the next cut, who knows. So I'm just going to put that in place. Do the same thing on the other side. Scribe it. See my little scratch? Again, cut it from this side. I want to cut it right. I want to put that, if you see where I have my, see where them cutters are? I got it right. It looks like I'm going to cut right in the middle, but the cutting part is more to this side. So when I hit this, it'll cut right off. I made that look good, didn't I?
Yeah, that was perfect.
Then I'm going to check my fitted, make sure I got all my pins. Now these are a lot easier to cut. Now why I'm not instantly soldering them in, again, the same way I did the Arduino. I don't want to, see how much play that has in it? So what I'll do is I'll do the same procedure. Now these are a lot easier to cut. You can actually cut these in while you got it on there. I can actually break them off if I want to. You know, if you, they're pretty simple. They're not tough to cut at all. They actually put little divots in these guys, so it makes it pretty easy. So I'm just going to put this all together, unsoldered, dry fit it, so to speak. So now I'm going to push it down. I'm just going to let kind of gravity hold it there. And once I'm happy with the orientation, I'm going to do the pins. So I'm going to do, because desoldering is sometimes can be painful, I'm going to do one pin on this side. I'm going to do one pin on this side. One pin on this side. One pin on this side. Now, I'm just going to kind of look. See, see how it's parallel? The two boards are parallel. It's not drifting over this way or this way. So I'm going to repeat the process on the other side. Still got soldering to do back there, but at least I'll have I won't have to worry about the orientation. So now I got each side, so now I can pull these guys apart. Set this aside, and now let's finish our soldering. That's how you can tell your iron's a little dirty. It wants to ball off up at the top. And it does not want to go down into the hole. It wants to, when you pull off, it wants to pull with it. I'm happy with that. So I want to check my my solders. Now, this is why we did the line up first, because now, you know how I was trying to get the pins like. Now watch this. It should just go together just like butter. Bingo.
Perfect fit.
And that's why that orientation when you're doing the pin is to make sure you line everything up first. So the next thing we're going to do is the Nixie tubes. There's some LEDs too we'd have to do. These are the Nixie tubes. I'm going to turn this over because these are things that Chad brought to my attention. I've heard of a Nixie tube, didn't really know exactly what it was. So I'm going to let Chad do some explanations on the Nixie tubes.
Nixie tubes really are the star of this show. They're a type of cold cathode display tube that were really commonly used in the 1950s, 60s, and early 70s for displaying numbers and things like test equipment and early calculators. Now, inside the tube are stacked metal digits from 0 through 9, and when a particular digit is energized, it glows with that classic neon orange color. They run at a higher voltage than modern displays, which is why circuits like this use driver chips and voltage conversion components. Now, even though LEDs and LCD displays replaced them decades ago, Nixie tubes have become very popular again for retro clocks and display projects like this one. Now, you can't help but love them. Now, that's enough talking from me. Let's get back to Brian and finish up this build.
All right, so now we're going to set this aside. We'll come back to that. We're going to give this board power. So we're going to look at the ground, the 5 volts. This is our wire we're going to have to start with. I was just talking to Chad, told Chad, I said, the stripe is the ground. And my grandfather used to tell me that stripe is negative. So I guess it always stuck with me. And you know, it's funny how little things stick with you like that. So I want to clean up the end. Get my, I got a little different way. I want to show you guys how I do this with wire. So I want to get a good little strip on it. Take my wire strippers. Now, I like to twist, but I'm not twisting real hard. I'm just giving it a few just to keep them together. Just like that. No more, no less. It's kind of you just have to do it a few times to see, because I don't want to make it where it's so tight. But now this is the neat part. This is the part I've learned with this rosin. It'd help if you turn it on. So what I do is because a lot of times when you flow solder, the individual strands want to run out on you. But I want to show you a little trick with rosin, how it makes it really simple. Most people probably know this, but this is a little trick I picked up when I'm doing some tiny wires or braided wire like that. So I have a start with a nice clean tip. Re-tin my iron. Let it get up to temperature. So I actually do this in the resin itself. Now I got a good coat of resin on there, on that wire. Now watch how easily this solder goes into this now. I don't know if you guys can see this, but see that? See how neat that is?
Yeah, it did go in there nice.
Re-tin it. So I think I'm going to want this wire to run off the back of the board. So I'm going to put my stripe, my negative. Should just insert inside this board. Now this is where you want to be careful, because you want to make sure that you don't have a little strand running over the next one, or the first time you plug it in, you'll know it. Of course, this is low voltage, but still. Get my tweezers. Give it a little tug. Okay, so that's up to the insulation. That one is not. So, little tip. I'm going to take this, because I got a little bulge of solder on there. So I should be able to take this, give it a little heat to it, and pop right in. Just like that. Separate my wires. Again, I'm carefully checking to make sure there's I don't have any small braid touching the other braid, because that will create an issue. I think there's a whole guy, it would probably just short it out, but there is another YouTuber that likes to blow stuff up. Now this is what I'm going to do both sides. And then I'll do what I call it the tug test. Give it a little tug, make sure it don't move. Cut my extra wires off. All right, so now we're good to go on that. So I don't know exactly how much length of wire I'm good. So I've put together the case, and I will tell you this. Okay, so you stack these on. This kit, and you know, Chad's always said, if something don't seem right or something it's hard to do, we're not going to hide it. This was tough to put together because the wood, the laser cut wood, was not drilled out perfect circles. So I had to kind of fight them as I went in. Then I had to take a screwdriver and kind of turn some of them on. It's just stacks of them. It was a little bit of a battle. I didn't want to, I mean, it's one of the things that it would be a 2-hour video. It didn't take that long, but I just went ahead and put it together. But just note that. I think what you could, to overcome that, you could take and you can use like maybe a drill press. But this wood is pretty brittle. I did notice that. So make sure you have a good sharp bit when you do it, and just kind of maybe bore them out, or even a rat tail file, something like that, to get it, because their circles are not perfect, and you can't put a circle in an oval, you know. So that they were just miscut a little bit. No big deal. I mean it's a kit. I'm sure if they put it together, might just be, you know, the day of the settings of the laser printer that day. Who knows? So now I'm just going to kind of mock things up. So I just want to see where, in relation to where everything's at, because the Nixie tubes, they'll stick out of here, and I want to have them sticking out equally distanced. When I put them Nixie tubes in, I want to see how far, I want them sticking out a little bit. And this part of the build is a lot of just trial and error. You know, in kits like this, they usually have an exact way to do it. But what I find is a lot of times, I don't know why, it just don't work for me.
Well, that's the neat thing about kits like this. You can fine tune them to exactly how you want them to look. You know, some people may like the Nixie tubes sitting back behind the front of it, but I'm with you. I think it'll look better if they stick out a little bit.
So then I'll kind of hold it down put my Nixie tube in. So now you see the distance. That's the distance I'm talking about, that distance right there. What do you think, Chad? You like that? Like about like that?
Yeah, I think so, because then you'll be able to see the glow on the outside too. I personally, I think you want to see that. But you know, that's one of the things with this kit, with the different standoffs. You can adjust that to whatever you personally like. But to me, I think that looks pretty good.
It's not too much. You don't think it's too much? I'd like it like that right there. So basically, there's nothing to cut on the back of the Nixie tube like this, which is even better. So now we're just going to take it back apart. Now, this is very important. Almost forgot. The orientations of this is very important. You'll notice that white paint in there, or whatever it is on that one pin, and then again, we have a little circle on the board to tell you where it goes. Now, I did notice one thing. There's 1 and 1, 2, but there's not, there's not 1 and 2. So I'll just go using the relation. I know that's pin 7, and then that's pin 7. So that's just where they printed the board. They didn't put it in the file to print a little silk screen around there.
And I will say about those Soviet Nixie tubes as well, you can't necessarily just look at the digits and assume you've got it the right way, because in the Russian tubes like that, those Cold War era tubes, they used the 2 upside down as the 5, so you could be looking at it and not know. So definitely look for that paint mark in there to make sure you get the orientation correct. Don't just go by the numbers.
And the big thing about these is equal distances. You don't want one sticking out further than the other. That wouldn't look right. We're getting to the good stuff now.
Yeah, the Nixie tubes are the coolest part of this build, I think.
Yeah, everything else is just a supporting actor to everything.
And one of the things that I always like to do on this channel is, you know, a lot of times tie modern stuff in with vintage electronics, and I think this is probably the epitome of that. You've got an Arduino running old Soviet Nixie tubes. So it's the perfect blend of modern and retro, which I really, really like.
So I'm happy with this first one. So I'm just going to hammer down on just one leg. How tolerant are these to heat?
I'm not sure. I've never soldered a Nixie tube before, but they're a cold cathode tube, so all those pins should just go to your wires inside, but I would think you'd want to take it easy on them.
Yeah, and if you don't know, just pretend like it's heat sensitive. Take your time, go slow, don't put a lot of heat to it. So all I'm doing now is I'm making sure that I have I'm at the same height all the way across. It can be a little tricky, and I also want the same space. So it's what's crazy is it looks like these legs are longer on this one than it is on the other one.
Well, and that's the thing with old Soviet electronic stuff too, is their tolerances a lot of times weren't very good. So you'll find variances between components. And for those of you that watched because I've had a couple of different Soviet electronics on here, different radios and boom boxes and things like that. When we've looked inside of those, you can see the wild variance and tolerances. They're normally built very ruggedly, but they're not very consistent.
Jed, you know why I'm only doing one leg at a time on each one?
Well, my guess is so that you can adjust where they're sitting on the board, make sure everything's straight before you lock it down. It's
a whole lot easier to put heat on one leg and to move something than it is to have to desolder. As you can tell. Okay, do you see how that one's sitting down a little further? Now, how easy would that be for me to do? I'm just going to take.
And you can always use your faceplate too to make sure your alignments are good.
I'm just going to put a little heat to this and pull it down just a little bit. So I just pulled it down just a little bit. Now it's back to the height. I only had to hit one solder, didn't have to desolder. I'm happy with that.
Yeah, those look good. Some of the reviews on Amazon, and I will leave a link below to this so you guys can get one if you want. But some of the pictures that people leave with their reviews, you can tell that they just stuffed all the Nixie tubes in there and went to town soldering them, and they're crooked and sticking up at different heights. So definitely take your time on this step, because that's going to be the focal point of this project when it's running, is those tubes. So, you know, take the time to get them right, or you're going to regret it every time you look at the clock.
And, you know, and then you get one day and decide, hey, I'm gonna fix that, and desolder, get your desoldering gun, your machine out, or however you desolder, and then drop a tube, you break a tube, something. So it's just better just to do this right the first time.
Mm-hmm. And I did, while I was looking on Amazon after I got this kit, I was looking, and you can buy the tubes by themselves. If you happen to mess one up or break it, or one of them burns out, you can get replacements. You can get, you know, a set of 2, 3, or 4 of them for, you know, $50 or $60. The thing I'll say about Nixie tubes too, I'm hoping that the program in that Arduino has a function that every so often, every minute or so, every couple of minutes, that it cycles all the digits on those Nixie tubes. Because a problem that you can run into with a Nixie tube is if you have one digit that's on more than the others. So, you know, that's going to be the case in your tens of hours. You're only going to have that one lit in that tube, and over time, that the cathode will basically start burning out, and that digit will get a lot softer than the others. So a lot of these Nixie clocks will be set up with a program that scrambles the digits every now and then, just to make sure that you're getting equal use and you don't have one burn out before the other. So we'll see when we power it up if it has that.
So Chad, I'm going to show you my newest toy for my boards. I'm having a little problem with this wobbling. Will you hand me the my solder stand? So now it's not bouncing around on me everywhere. Get this level. So now I'm going to double check these solders. They look good. So now we're going to move on to the LEDs. There's 5 LEDs. There's 4 going into each tube, and there's 1 in the middle. You'll notice the LEDs, the long lead is the anode, and the short lead is the cathode. So these they go in a certain direction. Very important on the LED. So you got to put them in the right orientation. So the long pin is the circle. That's what you got to really remember. So you'll see there's a circle on the back. So I'm going to put this in. Now there's going to be some bending involved here, and because I want to orientate that, I don't want to put it. I'll just demo. It's easier for me to show you than to talk about it, really. Again, I want to make sure these are all in the same height. The first one don't matter because you just go off of that height you did the first one. So I'm just going to put them in all the same height.
So those are designed to shine down through the tubes?
Yeah. It's kind of where the way that the video looked, it looked like he had them bent down and then back up. And when he turned it on, it looked pretty good. Put my last one in. This was the middle one. Along in the circle. So this one I'm going to do, I'm going to just leave straight up. Just ever so slightly like this. And this is, I'm kind of cheat, guys, because I kind of watched that. I watched a video and I see where he had it. And he had it about, he had a little higher than them when they were tall, but a little shorter than that. So I'm just going to leave it at that. That's the thing about these projects. You know, that usually there's more than one video of putting together, and you can kind of maybe pick up on one guy. You know, if you see something I'm falling short on or wouldn't do like that, you watch another one, and well, it's your project. Do it the way you want. So I'm going to cut my leads. And I'm going to bend these. So the way I see it, he bent it down, like so. This one, the middle one, he left straight. It's the bigger LED. Down, close to the board, like that. And basically, you're just flip around as such. Now I'm going to carefully do it at the same spot in every one. You just kind of adjust it as you need it. The final few steps. Now it's getting exciting. So we're going to do the same thing with our wire. I kind of noticed where that was out, so I'm going to cut that much off. Now this stripping, since this is going to go to a plug for the DC or the 110 to DC AC/DC adapter. Again, just that fine little twist, not too much, not too little. And the way I like to do these, again, same process. I like to get these things full with rosin, and I also use a wet soldering iron, what I call a wet soldering or a freshly tinned soldering iron. Get these all tinned over. Probably terrible for you, but I love the smell of solder smoke.
I'm sure there's worse things.
Right. All right, so my negative, the outside of this is going to, according to the adapter, if you look at the adapter, the outside is the negative. And if you're unsure of the negative, which one's the negative, this is just, we can just turn on our meter. We can touch the outside. See where we're getting continuity at. Now, notice that the long one is the negative, just like everything else. So I'm taking this, I'm going to put it in the hole, then sandwich that together as such. Do the same thing to the other side. Now this is going to be a little trickier because it's got a little flux on the end that, so I just have to trim it a little bit. We'll put this wires in such a way that it's not putting strain. So I want it nice and straight like that. Now let's solder them together. Wow. You know, for some reason, Chad, I always think I do better on smaller solders than bigger solders. I don't know why. What do you think that is?
I don't know. You do a lot of that surface mount stuff.
So now that I'm happy with that, if there's any, I'm going to trim off that little bit of part on that at one side. Boom. All right. So now my next step is I got the buttons to put on. Now it's really neat because these buttons on this, on the case of it, they just did some throw holes so it actually contacts the little buttons. That's kind of a neat way to do that. So orientation does matter, but they won't fit. If you have them in wrong, they won't fit. You can't put them in the wrong this way. They'll always go this way. I don't know if you can see that, but here, let me make it where you can see it. Pretty much they won't go in wrong. If you have to struggle putting these in, you got them the wrong way. So these buttons, they're a little bit trickier because they go in so well. I just take my tweezers, kind of smash one of the pins down to hold it, like that. Or your fingernail works too. Because you can kind of see they already have a little bend on them. Do my little solder standing thing, where I kind of hold the solder up like that. Use this. Now Chad's right there. He could help me here, but chances are you're doing this in your little workstation by yourself. So.
And once you get one pin done, it should hold it in there.
Right. I'm just going to do one pin on each one. And you know, here's another thing. If you could go, Amazon has them little alligator clip flexi things. I don't know what.
Helping hands.
Yeah, helping hands. So that could be used as your third hand. Had a little flicker there.
Mm-hmm. I know from my experience with putting those on, always make sure you double check to make sure your switches are still laying straight on the board after you start. Because I'll get ahead of myself sometimes and end up with one that's crooked.
Did you see one crooked on my board? Is that what you said that?
Maybe.
I did have one crooked on my board. Good point. I may or may not caught it because I would tell one of the pins were shorter, so I don't know. I'm not going to say I would. All right. So now at this point, we can turn our soldering iron out for the last time. Turn it off. So now this is the big step. So I kind of want to clean up a little bit here, get everything out of my way to get my, because now I want to do a good alcohol wipe of the board. And actually both boards. The most important step is this right here. If you don't do anything, this is, I want to clean all my, make sure all my leads are off of here, just push to the side. I like these mats, they got these little holes that everything just kind of falls down into. So make sure you have a good clean workstation moving forward. So now I'm going to take alcohol, turn it the other way, get my rosin, let's go ahead and cap that. We're done with that for the day. Start getting a good clean station when to do this. So what I like to use is alcohol, just regular, and this is 91%. You really technically should use a higher percent of alcohol, but that's what I have right now. So I'm just going to spray the board. It's alcohol, don't worry about it. Now this is a medium to fine toothbrush. I'm just going to go through. I'm going to get all the excess nasties off of it. You don't want to spray it like soak it. Alcohol evaporates pretty fast. So you just want to clean everything up. If you have a problem, always do that. Always check, make sure of this, because all these little pieces and solders and stuff, it's on the board too. You can't see it. And where I did that one spot, I'm going to get a little bit more aggressive, and I'll show you how to do that as well. So now I got a good clean board up on the top side. Now over here, so I'm going to take these guys right here. With these guys, like they're just makeup applicators. We'll get a little more aggressive with them. These, I do notice these kind of come apart. I don't like that too much. I'm going to go back to the Q-tip. Then they do make non-cotton tips that are better for cleaners, but I'm just going to get all that excess rosin off of there. Let that sit in some air. Do the same over here. Now I'm not going to do the other side by the where you did these, but I wouldn't too much worry about the top side on it because we didn't solder that much on there.
And he's right when he talks about cleaning those boards. If you guys watched the Tascam 122 video last week, after I got that belt changed and powered it up, I was having trouble with one channel on record. Turns out it was the op amp, and somebody had been in there before me doing a very bad solder job on it and left all sorts of rosin and flux and gunk all over the board that was basically shorting out that op amp. So Yeah, it's important to clean that off. It could cause all sorts of problems.
So just to tell you how much was on it, my hands weren't sticky. I start putting alcohol, mixing the alcohol, touching these boards, my hands are sticky now. So not probably the best way to do that, but put a little alcohol, get that off my hands. So now what I want to do is I want to just do a test. So I got everything together. This is where, guys, this is where it gets exciting. So I'm going to put the boards together. Okay. Now we're going to plug in. Chad, would you like to do the honors or would you with me?
No, go for it. You did the hard work.
So now let's see. Got my safety glasses on. Uh-oh.
Oh, there we go. So it Arduino has to boot up or something, I guess?
Yep. There's a little boot sequence there. So that was interesting.
Well, and I had seen on there that it starts off in 24-hour mode, even though it's the 12-hour mode, and then after a minute it'll switch.
So I'm just going to let it sit there, let it do its thing.
Well, it's interesting because you can see, if we look on the solder cam, that the 2 and the 5 are the same digit. That's what they did on those Russian clocks, is they just flipped the 2 upside down to make a 5. That's what I was talking about earlier with orientation on them.
Yeah, it is. It's kind of crazy. All right. So I'm back, and as you know, I did a grave sin. I actually soldered this wire on before I put the power supply plug in and the nut. Like I said, we're honest here. We make mistakes. I'm sure he'll show how I did it wrong. They'll put a funny video, I'm sure, of it, but I did it wrong. We fixed it. So now let's move on to assembly. So what we're going to do is, this is the steampunk version of this. I don't know if they make any other version, but that's kind of what it reminds me of, like a steampunk looking thing. Perfect. So now you can see that LED light is right there in the middle. This light right here. Now we want to put this down here like so.
Other way.
Let's do it this way. It's probably easier to do it this way. Actually, you know what? Let's go ahead and button this back up.
And just a note for everybody, if you're building this kit along with us, he's got the case upside down. That's a flexible top, so the flexible top goes towards the curve on the front and back.
So it's got that little arc, so you got to give it a little push here. A little nervous there for a minute because it didn't. That looks pretty good to me.
Yeah, it looks like it's in there.
So now we want to take the bottom. Now the way I watched them do this is they use this kind of like a stand, so they put this in the way you wouldn't think it would go.
All right, so it's the moment of truth. He's got everything soldered, everything's clean, and everything's been inspected. So now it's time to see if this thing will actually work when it's all put together. Let's plug it in. And there it is. You get that classic Nixie glow. Now there's just something about these tubes. Every digit is a real piece of metal that's lighting up inside the glass. And a huge thanks to Brian for walking us through this build and sharing some of his soldering techniques. Now just take a look at that. 4 glowing Nixie tubes sitting in a steampunk style frame. Now this is one of those projects where the technology is decades old, but somehow it still feels more alive than a modern digital display. If you're interested in trying this project yourself and helping the channel at the same time, I've left an affiliated link to this exact kit below. If you enjoyed this episode and want to see more builds like this, make sure you're subscribed to the channel and hit that like button. And if you want to see behind the scenes projects, extended builds, and the extra studio content that I can't always put in the main videos, check out the Studio Access and After Hours memberships. It's not for everyone, but if you're interested, it's available to you. I want to thank Brian again. Hope you had a good time on the channel.
I had a great time. I appreciate you inviting me on.
I'm sure we'll have Brian on again, but thanks for watching. We'll see you on the next one.